Alright, so yesterday, like I said, was our last day of coordinate grid lessons. Doesn't mean it's going away, but we are moving into service area. This is going to be the next thing that you guys are going to really need to understand and know. And then we're going to be taking our quiz starting possibly Tuesday, but most definitely on Wednesday, and then we have our first 7th grade lesson on Thursday of next week. Okay? Alright, so with your foldable today, you need to fold it in half so that you have example 1, 2, 3, and 4 on the outside. And then once it is folded, I want you to cut your flaps, but you're not going to be gluing it down just yet.
Yes.
Okay? So just cut your flaps and then why are we talking?
She was asking like,
She can raise her hand. Alright, so the biggest thing with surface area that you guys need to essentially understand is when you are looking at the 3D shape, this is why surface area is hard, because of this shape right here. Alright, because essentially you have to be able to break this thing down into individual shapes. Alright, and some of us are very, very good at geometry because we can see abstractly and we can think abstractly. Some of us do not do very good with geometry because it is very hard for us to see that there are 6 shapes to this figure right here. Alright? Now, the way that we're going to do this today is a strategy. Does it mean that you have to use it in future reference? Absolutely not. But it's a strategy. This is the 3D version of something. Oh, let me cut it. Use better words. So this is your 3D figure, right? Right there. This, and this is what we're going to talk about in a couple days, is your 2-dimensional net. Alright, this is, if I folded it up, becomes a 3D figure. But when I unfold it, I see individual shapes. Son, I will write you up today. So if that seat is not going to work for you, I need you to get up and move. You are not going to sit back there and distract the people around you. Do you understand me? I am talking to you. Yes or no? So make a decision. Are you going to be able to sit there, or are we going to need to just send you out already? Then get it together now. And if you're looking at this shape, what do you notice that makes this much easier to complete than that? What do you notice about this shape that I'm holding? Cooper?
you can find each side easier.
Right, because you can
Like
see.
You can see through the shape. Yeah.
Right. And so I'm essentially going to do my best today, and that's why you need some colors, to identify the different shapes on this 3D figure. Alright, so when I use a color, you're using a color. When I am looking for a pen, when I'm using my black pen, you're using your black pen. Or black, your pencil, sorry. Apologies. Alright, so it says find the surface area of the rectangular prism. Now, you will notice that shapes are called, they're identified by their bases. So this is a rectangular prism, which means that technically the bases are rectangles, and then all the other sides are rectangles. You're going to see that we're going to talk about a triangular prism today as well, and you're going to see why, because the bases are triangles and all the other sides are rectangles. When we talk about pyramids, you'll see why a pyramid is different from a prism. Okay? So, rectangular, what do you think that means for essentially finding the surface area? What do you think that means for finding the surface area? Jack?
You just do regular area.
Right. We're going to try to break this shape into smaller, one at a time rectangles. Alright, so the formula that we are going to be using for this is what? If it's a rectangular prism, length times width. Alright, so we have our rectangle, and we know that that is going to be length times width. Alright, so when I cover up everything, and this is something that you're going to be like, well, we can't do that on an iPad. Yes, you can. If you use both of your hands and your iPad is sitting up when you're taking your quizzes and your tests and whatnot, you can do this. And you can cover up everything but one shape at a time. Alright, so what shape does this look like? Ace.
Rectangle.
Looks like a rectangle. So this shape right here, I'm going to outline with one color. Now, Ace, do I have a length and a width for this one?
Yes.
Yes, but no, right?
Yeah.
I have a length and a width, but do you see two numbers for that?
No.
No. So for my first rectangle, I know that I'm going to multiply by 6 because that is my base. How do I find, or that is my width. How do I find my length? Michaela?
Well, with the other shapes, it says that the length of the other rectangle is 12, so we just move that since it's equal to that arc.
Right, because you know that the opposite side of a rectangle are what?
Equal.
Equal. Alright, so this actually becomes a 12. So now do I have the information I need to solve for this rectangle on the front?
Yes.
Alright, so I'm going to do 6 times 12, which gives me what? Not 72 inches squared. Now, because this is a rectangular prism, what do I know about this shape and the back shape? What do I know about this shape and the back shape? Ethan? They're the same. So Ethan, can I just multiply 72 times 2? Alright, so I'm going to do that. So times 2, which gives me what? Raise your hand. Jackson?
I think 144 inches.
There you go. Alright, so I also want you to take, and I want you to identify this back rectangle as the same color as the front.
What about the side one?
We're not there yet. One at a time, baby, one at a time. You don't want to get too far ahead and get confused. Yes.
I don't have one.
You don't have a paper? Do you have one?
We have an extra.
Alright. Alright, so we found one of our rectangles. Let's look at the next rectangle that we're going to be looking at. And that one is going to be right here. Alright, do we have two numbers that we can multiply together to find the area of that rectangle? Alright, Cooper, what are they going to be?
5 and 12.
Yes. So I'm simply going to do 5 times 12. Raise your hand and tell me what does that equal.
60 inches.
And then, do I have another shape that is exactly the same as that one?
Yes.
And I can multiply that by 2, which gives me 120 inches squared. So take a different color and identify these two. as being the same. So now that leaves us with just our top and our bottom. All right, so if you cover everything up, looking at the bottom, what shape do we have? Be careful with this one. What shape do we have? Mason? Nope, be careful.
I know what it is, but no.
How do you? My bad.
Do. It's what we've been doing the whole time, kid. What's it called? No! It's a rectangle. Oh, Lord have
It's
mercy.
because it's like diagonal in the picture.
Okay, okay. I give it to you, Mason. I'll give it to you. Shh. So, guys, yes, technically you are correct. It does look like a parallelogram, but we're not doing parallelograms. We're doing a rectangular prism, which means all the sides have to be straight. So, Mason, what two numbers am I using?
6 and 5.
6 and 5. So for this last one, 6 times 5, Mason, what does that give me?
30
Just 30?
inches.
Thank you. And Mason, is the bottom the same as the top?
Yeah.
Can I multiply that by 2? Which gives me? Alright,
Inches 40.
got you. And just identify that top one. So now we have our answer, right? We have 144, we have 120, and we have 60. So which one is our answer? Which one is our answer? Raise your hand and tell me. River. So it's essentially just like an irregular shape then. So we just found the area of all the individual shapes and we're adding them together to find the area of the whole shape.
Yes.
Okay. So when you add 144, 120, and 60, raise your hand and tell me what do you get? Olivia,
424 inches.
200 what?
424. Wait, what? Oh my gosh.
Shh, guys.
There's
300
24 inches.
squared. It's not cubed because no matter what we did, Jason, how many numbers did we multiply together? Only 2, right? So then therefore we're not multiplying a third, so it's not cubed, it's still squared. And that's a big thing that we think because we've done so much work that we're cubing it or putting it to the 4th power, we're not. Because at the end of the day, we're still only multiplying 2 numbers to find the area of one shape. Okay? Yes?
So is there like, so if you were to do it like regular area, like 6 times 5 times 12, you definitely get a volume answer.
Yes, because you just found the volume. 6 times 5 times 12 is the volume of a 3D shape.
Oh.
Yep, good question. Nothing wrong with that. All right, so now let's slide over to our next example of another rectangular prism. So I want you to look at this one, and I want you to look at the one we just did, and how are they different? Let's have a quick conversation about how are they different. So everybody thinks they're the same?
No.
All right, Hunter, how are they different?
Example 2's rectangular prism has longer sides.
Has what? Longer
Longer
sides?
sides.
Okay. All right. Anything else that is different? Michaela?
It's skinnier.
Skinnier. Okay. Is it still made up of rectangles?
Yes.
So therefore, what is the formula that we're going to be using to solve this problem? Raise your hand. Alexa. Base times height, or some of us like to say length times width. Doesn't matter. Both the same. All right, so let's start with this side over here. For this rectangle, what 2 numbers am I multiplying together? What 2 numbers am I multiplying together? Corbin.
7 and 3.
So I'm gonna do 7 times 3, which gives me what? 21, no, meters squared. Alright, so this one right here, does it have a matching side? Yes, it does. It's this back side right here. So I can multiply this 21 times 2. Raise your hand and tell me what is 21 times 2. Joseph?
42.
No.
Meter squared.
There you go. That's better. All right. Now, I want to look at the front. This shape right here. I only have one number. Where do I find the other one? Cooper?
Since you know it's 13 the height is all the same. So it's gonna be 9 times 3.
Okay. So 9 times 3, Cooper, what does that give me?
27
Nope.
meters squared.
Yes. Does it have a identical shape?
Yes.
All right, so I can multiply by 2. Cooper, what is 27 times 2?
54 meters squared.
Okay. All right, and then the last one is this top shape. Now technically, looking at this top shape, I don't have any numbers. So how do I figure out what I'm gonna be multiplying? All right, Jack.
There's 97, and you use that for the other two.
So there's also a 3. I use that one too.
That's the width, no, you do it, just use base like that, and I put base. Or, yeah, they touch it.
So how do you know that 9 is the base though?
Because that's what we use all the other ones.
No, we didn't use 9 for all the other ones.
We use that for one other one.
So? I'm not saying you're wrong, I'm just saying I need more evidence that you're correct. So I'm a slight believer, but I'm not a full believer. Guys, so he's saying that we should be doing 9 times 7, but I'm questioning and I'm saying why? Like, why are we using 9 times 7? So you're right, but I need you to tell me why, kind of thing. All right, Jenna Lee, what do you think?
Because it's the length.
Oh, yeah.
And the width.
No? It's the length and the width of 2 others. Well, how do I know it's the length and the width of this one? I need more. I need to be persuaded. Christian?
Because because they're the same exact length and going up.
Nope. 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 Caleb?
Because the bottom shape is the same as the shape on the top.
No, it's not.
At the
So,
very top.
so you're saying this bottom shape is the same as that one?
No, I'm talking about the base one, the one on the very.
So this one
The one that we haven't done. Yeah, that one.
is the same as this one?
Yeah. Yes. Yes.
Okay. So then how do you know that how do you know what numbers you're multiplying?
Because if they're the same size, they'll have the same size.
But what are the numbers?
9 and 3.
Are you sure?
Yes. Yes. Yes.
So I'm supposed to believe you and Jack with both of your reasons.
And me, yes. And me.
And me.
I agree.
I agree.
But hey, you're right. It's 34, 33, 33 verse 1. Okay, I guess. So because originally I'm looking at the top one, right? And the top one has no numbers. But with Jack and Caleb's convincing, they're like, look at the bottom one.
And everybody.
So the bottom one has those 2 numbers. So sometimes when you guys are looking at these shapes and you can't find the numbers, try to find that same shape somewhere else on your figure. That was my whole point. Okay? All right, so we are going to do 9 times 7, which gives me what? Raise your hand. Corbin.
63.
No? Yes. Can I multiply that by 2? What do I get when I do 63 times 2? Perfect. All right, so what do I do with 126, 54, and 42? Add them up. Raise your hand when you have them added together. I don't need any noises. All right, River, what'd you come up with? No. Yes. All right, so questions about just the rectangular prism. What did you notice that we used, no matter what the rectangular prism looked like? What did we use that was the same in both? Caleb. Length times width or base times height, because they're all what? What are all of these shapes? Rectangles. No matter what, they're all rectangles. All right, so close your top 2, and let's look at the examples for number 3. Now, this is a triangular prism, and remember I said your prisms are named by their base. Your pyramids are named by their base. So therefore, the reason this is a triangular prism is because the base is a triangle. So with knowing that, what's one of the formulas we're going to be using? One of those formulas.
Length times width or base times height divided by 2.
Okay. And then what are the other 3 shapes?
Rectangles.
Rectangles. So what am I going to be using?
Base times height or length times width.
All right. Let's start with our triangle right here. What's my height, what's my base for this one? What's my height, what's the base? Gabriel,
10 times 12.
how did you come up with 10?
If you look at the bottom triangle, and it is 10 and 13, but we don't use 13. We could, but actually no, you couldn't.
Don't change anything.
Yeah, it's 10 and 12.
Yes. So because the base down here is 10, we know that this one is also 10. So what's 10 times 12? Corbin. And divided by 2.
60 feet squared.
Yes. Now, I'm going to, if this will focus. Of course you will.
Don't you just multiply by 2?
Well, I'm going to tell you something. And if this makes sense to you, use it. If it doesn't make sense to you, act like you never heard it.
Okay.
When you are dealing with triangular prisms or when you're dealing with pyramids, you do not have to divide by 2 in your triangles. Do you know why? Do you know why, Jackson?
Because there's 2 triangles, so if you divide by 2, and then you just add the other one, it's the same.
Right, so you're essentially dividing by 2 to multiply by 2. All right? With your pyramids that are squares and rectangles, same thing. You do not have to divide your triangles by 2. You actually multiply just this number by 2 because you have 4 triangles. So if you divide by 2, you're ultimately multiplying those all by 2.
It's just an extra step.
It's an extra step. Now, if it doesn't make sense to you and you're like, what? You just keep right on dividing by 2 because you're going to see me divide by 2.
Second part.
Okay? Yes.
I'm just making sure. Basically, you just don't divide them.
When you're dealing with triangular prisms
Yeah, that's what I'm saying.
or pyramids.
Yeah, you
Yes.
just don't divide it.
Yeah.
Just
But you are gonna see me on our example divide by 2, because that's what I want you to ultimately understand that you have to do. Yes, sir.
So when it's one triangle and it's like split down the middle for the height, sometimes I'll just like if it's like 10, I would do 5 times 12 and it's not divided by 2. Does that work?
That's fine, but you will have to divide by 2 because if you do, because ultimately you're gonna want 120 because there's 2 triangles.
Well, for like a singular triangle.
Yes, that would be fine. Yep. And because that's technically the 7th grade way that I'm supposed to teach you is half the base times the height. So what you just did is half the base times the height. Because you're halving the base and multiplying it by that height. So yeah, no, that's fine. I just don't teach the 7th grade way because we've heard base times height divided by 2 so much. It's just a lot more comfortable for us. But your 7th grade teacher will appreciate that you know that and I didn't teach you. All right, so that's one triangle. We know that we can multiply this by 2 because we have to. So I know that I'm gonna end up with 120 feet squared for my triangles. Now, looking at this rectangle right here, what 2 numbers am I gonna be multiplying together? Ace. Okay, well, again, just look and tell me what 2 numbers you see.
20 and 10.
Okay, so we are gonna multiply 20 times 10. Raise your hand and tell me, what does 20 times 10 give you, Mason?
300 meters squared.
What?
Oh, 200.
Feet squared. All right. Now, I have a question. Do we have another 20 by 10 rectangle?
No.
No.
There's 13.
The next one is 20 by 13.
We do not. So therefore, this is why it's a little bit different than our rectangular prisms. So that is 200. We're not doing anything with it. We're not multiplying it by anything because there's only one 20 by 10. Now, we do have this one right here that is going to be what 2 numbers that we're multiplying together? Rock?
20 and 13.
20 and 13. What do you get when you do 20 times 13? Cooper?
160.
Cooper, do I have 2 of those?
No.
Alright, so this front one right here,
Oh,
do I have one that's also the same?
yeah.
Yes.
I do?
Yeah, the back. The one in the back.
So if I,
Yeah.
so that one's behind it. So then I can multiply this 260 by 2. And that gives me, what, 520? So what do I do with those 3 numbers? Cooper,
Yeah.
add them up. Stand up when you have your answer. Cora, what'd you come up with?
I came up with 840 squared.
Yes. All right, the last one. So now looking at this one and looking at the one we just did, how are they different? Joseph, stop. How are they different? So looking at this one, and looking at that one. How are they different? Jack?
So looking at it at different angles.
So possibly looking at it at a different angle. Okay? Caleb?
Like this one looks like it's flat, and then the other one looks like this.
Okay. Alright. Michaela?
The triangles, like I don't remember the names of triangles, but the one on example 3 has like I think it's called an isosceles.
Where two sides are the same?
Yeah.
Okay. Well, doesn't this one have one that?
Yeah, but it's like a different kind because
It's not a different kind of cell.
no.
It's 5, 5,
This
This one
Oh, look.
is 13, 13, 10.
Okay, can I go?
Yeah, come on.
So, but right here is the base, and that is where our
Your height?
height comes from.
Okay.
But over here, this is the base, and that's where our height comes from. It doesn't come from one of the sides of the rectangle.
Neither does
At
that
the
one.
bottom. Our height comes from
The middle, right?
yeah, but it's one of the sides of the rectangles, like
So is
of the
this one?
bottom rectangle.
So is that one? 'Cause that's the bottom rectangle.
Same shape,
It
just
can't-
put at a
it can't
different,
be.
like just laying down.
So it's
It's
exactly.
the same thing. It's just laid down a different way.
Right. Right. So no matter how hard Michaela tries to disagree with me, you can't agree. You can't disagree with me on this one. Shh. All right, listen. So my point of asking what's the same, guys. My point of asking what is the same is, or what's different, or looking at both of them, nothing. We're still going to do the exact same process we did with the last one. All right. So starting with our triangle, what is our base? What is our height? Or I'm sorry, what's the formula? My fault. What is the formula we're going to be using for a triangle? Jeremiah.
It would be base times height divided by 2.
Perfect. All right, so base times height divided by 2. And our rectangle, what's that formula? Hunter.
What base times height?
Perfect. All right, so for our triangle, what numbers, let me rephrase that. What's my base, Michaela?
8,
What is my height?
3.
So Michaela, do I divide this by 2 or do I leave it?
You leave it because there's two of the same shapes.
Right, because there are 2 of the same shapes. Yes,
But on the other triangle, it says 3 centimeters, right?
they're both
That's
3.
the same thing.
Yeah.
They're the same.
So this is
My
the
bad.
same.
Okay.
No, you're good. You're keeping me in line because you know I don't follow the rules. All right, so technically you do not have to divide that 24. Again, for example purposes, I am going to. So both of those equal 12. So 12 plus 12 will ultimately give us 24. All right, rectangle. Which rectangle do we want to do? Let's look at the front one. What are the 2 numbers? Brock.
15 times 5.
So 15 times 5. Raise your hand and tell me what is 15 times 5. I like the friends that have Jeremiah.
75.
75. Just 75?
75 centimeters squared.
Perfect. All right, so that's the front one. Does this front one have one that is similar?
Yes.
It does. Which one? So if the front one is 75, then this back one is 75, right? So I can multiply that by 2? No,
Oh, wait, no. It's
no.
The 3 is for the height of the triangle.
Oh, no.
And the last rectangle is this one right here. What 2 numbers are we using for that one? Alexa, which gives me Jack.
120.
Nope.
Or 120 centimeters squared.
Yes. So what do we do with 150, 120, and 24. Add them. Stand up when you have your answer. Please be quiet. Emily, what'd you get?
I got 2 centimeters square.
All right. Go ahead. You have a question? No, not in the middle of the lesson. You are going to be gluing this down on your first page. Close your notebooks when you are done. Well, not that I know. You might, but I don't believe so. Probably not children. All right, so for the rest of today, you have, and I'm gonna show you kind of where to go and everything, but you have 6 problems you're gonna be practicing. It's gonna have to do with surface area, and volume. Do not forget, we still need to remember area, we still need to remember volume. Now,
Pardon the interruption. The following students need to come to the auditorium with their iPad. Vigo Byer, Zoe Butler, Christopher Matthews, Annabelle Miller, Driston Rojas, Alicia Stevenson, Kyra Kelp, Lucas Riggs, Anna Willis. Again, the following students need to come to the auditorium with your iPad. Vigo Byer, Zoe Butler, Christopher Matthews, Annabelle Miller, Driston Rojas, Alicia Stevenson, Kyra Kelp, Lucas Riggs, and Anna Willis.
okay. How many of you guys remember this homework that I gave to you the day that I think my son was sick that day?
Yeah.
And a ton of you guys were like, I don't know what to do. I can't figure this out. This is so hard. Blah, 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 blah. Because that's all I heard that day. I got about 782 emails about how hard this was.
Yeah.
So, now that you've gone over surface area, now that you kind of have an example of surface area, this is going to be your homework again tonight. What you're going to do is the ones that got turned in, I marked right or wrong. Like it was either right or it was wrong. Like there's an X if it's wrong. If it is right, then there's nothing. But you're essentially going to go back and correct these. Okay? So if you get it back and you have no X's, then guess what? You have no homework. If you get it back and you have 1 X, then you got one thing to do for homework tonight. Okay? If you never turn this in, you have a lot of work to do tonight because you have to do it all in your notebook. Because I'm not giving more copies. All right? With your classwork, the 6 problems that you're working on, you're going to need to go on Canvas, not right now, just sit still. You guys have also seen these task cards before. Because this was another one of those, I don't know, like it was insane. I'd never heard children complain so much in my life. So you are doing problems number 2, number 4, number 5, number 6, 8, and 9.
So all the ones that are listed on there.
Right, all the ones that are listed here, all the ones that are listed on the Canvas page, and all of your work goes right here on this page in your notebook. Now, if you need to do, like if you need to turn the page in your notebook because you don't have enough room on one page, that is fine. Turn the page. Does that make sense? Do not squeeze it all into this one page if you need more. I'll wait for you guys to stop talking so I know that you're paying attention, and I'm not going to get an email or a text message or a remind message or any kind of message saying I don't know what to do. I tried very hard not to make this super difficult, give you a little bit of a review and a little bit of practice of what we did today. Alright, so while you're working independently. If you are confused, if you need help, if there's any doubt, you need to come and ask me for help. This is your opportunity because there's not a whole lot of times in class where we actually get time where you guys work and just work. Okay, so this is the opportunity. You have 6 problems you are working on. If any one of them you do not understand, you need to come and see me. Does that make sense? When you are finished with your 6 problems, come and get your homework if you turned it in. If you did not turn it in, then turn the page in your notebook.
You want us to show you this?
Yeah. You will be turning the page in your notebook and it will be titled Surface Area Air Analysis Redo. Okay, but obviously I don't want you to put that on the page yet in case you have to use this backside. Does that make sense? Okay. And it's also up there on the board surface area homework from last Monday, 10-3. That's the same thing as this. All right, any questions on what you're doing? All right, you may move around the room. You may pull a chair up to the table. You may sit in a cushion. I don't really care, but you need to be working.